Hi, today I'm excited to talk to you about the transformative power of serverless architectures in the world of software development and cloud computing. For nearly a decade now, serverless approaches have been revolutionizing the way organizations build and deploy their applications. However, some companies still maintain a reluctance to fully embrace this model. So let's walk through the key benefits of serverless and how it compares to traditional server-based setups and how we can migrate a server-based architecture to a serverless architecture. The primary advantage of serverless is the elimination of infrastructure management overhead. With serverless, the entire burden of keeping systems patched, updated, and running smoothly is offloaded to the cloud provider. Your team can focus purely on writing code and delivering value without having to worry about the underlying infrastructure. Another crucial benefit is the enhanced security posture. In a serverless world, there is no single identifiable server that hackers can attempt to breach. All security updates, OS patches, and infrastructure hardening are handled automatically by the cloud provider, significantly reducing the attack surface. Serverless architectures also offer unparalleled scalability advantages. You can easily add more compute resources to handle increased traffic or workloads without having to provision and manage additional servers. This elastic scaling happens automatically, ensuring your application can handle spikes in demand without any manual intervention. Finally, the cost optimization benefits of serverless are quite compelling. With serverless, you only pay for the compute time and resources consumed during actual execution of your application logic, leading to significant cost savings. Overall, the benefits of serverless architectures make a strong case for organizations to seriously consider this approach. While the migration process may require some upfront effort, the long-term advantages can be transformative for businesses looking to maximize developer productivity, application resilience, and operational efficiency. Next, let's dive into a simple diagram to illustrate how a serverless architecture differs from a traditional web application setup. In a typical web architecture, you have a front end, a back end, and a database. Users access the front end, which then makes calls to the back end to fetch or update data in the database. In a serverless approach, the front end is hosted in an S3 bucket and served to the users through a content delivery network like AWS CloudFront. This ensures fast, reliable delivery of the front-end assets. When the front-end needs to interact with the back-end, it goes so through an API gateway. The API gateway acts as the entry point, handling all the incoming requests from the front-end and routing them to the appropriate serverless compute services such as AWS Lambda functions or step functions. These serverless compute services then handle the necessary business logic, making any required database calls to retrieve or update information. The beauty of this approach is that you don't have to manage any servers or infrastructure. The cloud provider takes care of provisioning, scaling, and managing the underlying resources on your behalf. Now, we will go through our high-level plan to migrate from a server-based architecture to a serverless architecture. This transition will unlock new opportunities for our organization and help us deliver even more value to our customers. So these are the high-level steps of the migration plan, and we will now dive deep into each of them. The first step in our migration journey is assessment and planning. We will conduct a thorough analysis of our existing server-based application and infrastructure to identify the specific components, functionalities, and workloads that can benefit from a serverless architecture. we will assess the technical feasibility, cost implications, and timeline for the migration and develop a comprehensive plan with a phased approach to minimize disruption. During this phase, we will carefully evaluate the current state of our server-based system, looking at factors such as resource utilization, scaling challenges, maintenance overhead, and overall operational complexity. By understanding the pain points and limitations of our existing architecture, we will be able to make informed decisions about which parts of the system can be effectively migrated to a serverless model. Engaging stakeholders and obtaining buy-in for our migration strategy will be crucial during this phase. We will work closely with cross-functional teams, including developers, IT operations, and business leaders to ensure that our migration plan aligns with the organization's strategic objectives and addresses any concerns or dependencies. Next, we will focus on designing our new serverless architecture. We will evaluate and select the appropriate serverless services that align with our application's requirements, considering factors such as event-driven triggers, API integrations, data storage solutions, and any necessary middleware or orchestration services. Our design process will involve identifying the required serverless functions, their event triggers, input-output parameters, and the overall data flow. We will ensure that the new serverless architecture addresses scalability, reliability, security, and cost optimization requirements, leveraging best practices and industry standards. During this phase, we will also explore opportunities to optimize our application's architecture and leverage the inherent benefits of serverless computing, such as automatic scaling, reduced operational overhead, and pay-per-use pricing models. With the architecture in place, we will move on to setting up the serverless infrastructure. We will provision the necessary serverless services and related resources in our chosen cloud platform, configuring the event triggers, API integrations, and data storage solutions to support the new architecture. Implementing robust security measures, access controls, and monitoring mechanisms will be a key priority during this phase. We will ensure that our serverless infrastructure adheres to the highest standards of security and compliance, protecting our data and systems from potential threats. Additionally, we will optimize the serverless infrastructure for cost, performance, and scalability, considering factors such as call starts, memory allocation, and execution duration. By carefully managing these aspects, we will be able to maximize the benefits of our serverless architecture and ensure that it aligns with our operational and financial goals. Next, we will refactor our existing application code to leverage the new serverless architecture. We will break down the application into modular, event-driven serverless functions that can be independently deployed at scale. We will implement the necessary event triggers and API integrations between the serverless functions, optimizing them for performance, cost, and scalability. During this phase, we will also explore opportunities to modernize our application's architecture, leveraging the flexibility and scalability of serverless computing to enhance the overall user experience and unlock new capabilities. Before deployment, we will develop a comprehensive testing strategy to validate the migrated serverless application. We will conduct unit, integration, and end-to-end testing to ensure the serverless components work as expected, and perform load and stress testing to verify the serverless architecture's ability to handle the expected workloads and traffic patterns. By thoroughly testing the serverless application, we will be able to identify and address any potential issues or bottlenecks, ensuring a smooth and successful migration. Next, we will implement a phased or canary deployment approach to gradually migrate users and traffic to the new serverless application. We will establish robust monitoring and observability solutions to track the performance, health, and cost of the serverless application and continuously optimize the architecture based on usage patterns, cost, and performance metrics. During this phase, we will also develop a plan for incident response and disaster recovery for the serverless application, ensuring that we can quickly respond to any issues and maintain the reliability and availability of our services. The final phase of our migration plan is training and knowledge transfer. This is crucial to ensure the long-term success of our serverless architecture. First, we will provide comprehensive training to our teams on the new serverless architecture, best practices, and management procedures. This will cover topics like serverless function development, event-driven programming, and cost optimization. We will also thoroughly document the serverless application's design, deployment, and maintenance processes. This will serve as a valuable reference for our teams, preserving institutional knowledge. Establishing a knowledge sharing culture and ongoing learning opportunities will be a key focus. We will encourage our teams to stay up to date with the latest serverless trends and best practices through industry events and online communities. Finally, we will identify and nurture internal serverless champions. These individuals will be the driving force behind the ongoing optimization and innovation of our serverless architecture, serving as mentors and evangelists. The migration to a serverless architecture requires careful planning and a commitment to continuous improvement. By following this refined plan, including the critical training and knowledge transfer phase, we can ensure a successful transition and unlock the benefits of serverless computing. Hope to see you in another video.